About a year ago, Ethereum cat herders started a working group to help push the best URL URI proposal to final status to become a standard, and we succeeded. If you are interested in learning about the latest URL standard that helps Web2 users to directly access the on-chain Web3 content, continue listening. Welcome to PEEPanEIP episode 106. I'm Pooja Ranjan, and we are joined by an ERC author to discuss an EIP to revolutionize EVM call messages. ERC-4804, Web3 URL to EVM call message translation, was originally proposed in February 2022 and is in final status. To talk about this standard, we are joined by Zhou, the author of EIP. Welcome to the show, Key.
Yeah, many thanks for the introduction, Pooja. And so my name is Zhou. I'm currently working on ERC-4804, Web3 URL to EVM call message translation, or sometimes we call it in a short name called Web3 Access Protocol. So before I introduce the protocol, let me briefly introduce myself. I have been actively working in Ethereum ecosystem and discuss and wrote a lot of articles, comments in Ethereum research and magician. You can should be able to find all my outputs there, and also author and co-author a list of EIPs, including 4804 and also a list of others. And before that, I was a former Facebook, Google EMC Dell software engineer and got a PhD from Georgia Tech. I also have been working on closely with Ethereum Foundation and received multiple grants from ESP program, including data availability sampling research and also proof of storage using Ethereum smart contracts. So what is Web3 Access Protocol? It's defined in ERC-4804 and it's already finalized thanks for the EIP editors 2 months ago. And the goal is able to render the web objects hosted by smart contract directly without using any centralized components or for example, other systems like IPFS. And it is very similar to HTTP, except that it's the authority part here is in HTTP is, for example, DNS or an IP address. It is replaced by a smart contract or the ENS name that map to a smart contract. And so, first of all, why we need Web3 Access Protocol? Since we already have multiple protocols, IPFS, we have HTTP. One observation when we start this protocol, start with this EIP, is that we observe that more and more NFTs, they are moving towards to be fully on-chain, fully on Ethereum. This is a couple of a few NFTs that we found in market, but that there may be much more. For example, cyber brokers, nums, moonbirds, unblocks. The reason they would like to have the NFT to be fully on chain is that they would like to have the users not only own the corresponding token of a smart contract on the Ethereum, but also all the data definitely on chain, because since 2017, 2018, with the early NFTs, people found a lot of data, for example, images. Even people pay a lot of money by the NFT, but those data just because they rely on centralized servers or IPFS, they just disappear after a few years. And that is something basically break the what the Ethereum kind of like say, hey, the user actually own all the things, own all the not only the code token. So that's why now more and more NFTs, they are now moving towards these directions. And so I also take a look at how they be able to support fully on-chain NFT, investigate their smart contracts from EtherScan, and see how they're able to render this data. And we are quite surprised that even though all the data are now available on chain, but there's still no way to render this object directly. Instead, in their token information, they're still using HTTP server, like Moonbirds and or the IPFS link to ask the users to find the corresponding metadata or images. So that's something that I say, hey, why we already have the data, why not we just directly be able to browse these images directly, so that we do not need to rely on any third party like DNS, HTTP server, or IPFS, so that in the future, when there's an NFT that is built on top of Ethereum, they can use Ethereum native protocol, that is our proposed Web3 Access Protocol, be able to directly render these images through smart contract and call the corresponding method, for example, random or random blocker, and be able to directly display those images without any further third-party trust. And this is the biggest motivation starting for the Web3 Access Protocol. And so how to use Web3 Access Protocol? Actually, it is very, very similar to HTTP. Sometimes we call it decentralized HTTP. It is consists of a decentralized authority, which is a contract by its address or a name service, like for example, ENS. And there's a way to call the contract, basically how we are able to translate an HTTP path and query and to the corresponding core data that the EVM can be accepted. And there's a way to tell how to return the format of the data, including MIME, so that we are able to, for example, not only to be able to display images, but also be able to return the corresponding data in more complex format. For example, I can query the balance of the user. I can query the corresponding token info of any token URI. So we also build a website, Web3 URL, to list all these examples and cases. And besides how to use this Web3 URL, we also need a way to access EVM with Access Protocol. So we are also working on the gateway, which is called Web3 Ether.io, which is the current gateway for supporting the Ethereum. For example, our homepage that is Web3 URL, it's already deployed onto the EVM and mapped to the corresponding contract and display all our homepage. And it's either be accessible via Web3 Access Protocol through Web3 URL.eth, or it can be accessed via our gateway, which just plays the name of the contract in the subdomain, and then put the rest of the path and query in the HTTP gateway. And we also have a Firefox extension, which I can give a demo later, so that it will just help to directly type this full URL, and it will automatically translate to the corresponding gateway link. And also, there are a lot of community members that are very interested in the whole idea. They were really buying these ideas and believe this is the future of Ethereum. So one of our community members is called Nan2. He is very famous with all the browsers, like for example, Electron and also Chromium. So he created an EVM browser while it's still in the early version, but right now it is already also natively support Web3 URL. So here on the right-hand side is a screen snapshot from the application, which I just typed Web3, /vitalikblog.eth, which we maintain a copy of Vitalik's personal website on top of Ethereum. And now this browser can directly pass this link and call the Ethereum messages and then return the corresponding website, so that the users actually do not need to touch any HTTP or DNS, but directly access the Vitalik website that persisted on the Ethereum forever. So this is a really, really amazing project. And so with all Web3 URL, we are now able to support a lot of interesting applications that are on top of Ethereum. So one example is on-chain NFTs. So here we take a Cyberblock example. We have a way to, we first investigate how we is able to retrieve their on-chain data of their images. And then we wrote a smart contract, which to wrap corresponding the images calls so that we are able to combine them, so that we are with a single method to return a SVG file and then return to the front end. And then we registered a name and points this name to the contract that we deploy on top of Ethereum mainnet. And so now everyone is able to access these images directly on top of Ethereum using our Web3 Access Protocol in this link. There's also more applications. We are also experimenting a very interesting idea. We download the whole Vitalik's blog, which is about 40 megabytes. And then we also upload all the blog to a smart contract on Arbitrum Nova, because right now using Ethereum mainnet is still super expensive. So using Arbitrum Nova, we are able to deploy upload all the blog using about 0.13 Ether, and we upload the whole blog, and right now the users are able to directly access the Vitalik blog either using our gateway or using our the community's native browser. And we also report this idea to the community, which receive a very good receptions, and people are discussing all these ideas besides Vitalik blog and all other concerns like, for example, gas costs, and also, for example, where to storage will be better. And we are also exploring more applications because now we are able to use a smart contract and to do more complex things, like, for example, to run all kinds of the application, decentralized application logics, for example, decentralized Blogger, decentralized Dropbox, or decentralized email, decentralized Git, or decentralized Craigslist. There are a lot of ideas. Actually, they're coming from communities, and we say, hey, welcome to be on top of that. And then let me know if you have any questions, issues, and that we are able to help to address those problems. So definitely when we gradually roll out the whole ideas and with more like participation from communities, we also have found a lot of blockers that basically make the, so for example, to make the project proposal to be more successful. So there are a couple of blockers here. One blocker is that how we are able to have more widely adoption with native browser support, especially with popular browsers. So this is a very key for massive adoption. And we believe there's a huge impact on both Web2 and Web3 users, because now the Web2 users, they can directly type with some Web3 Access Protocol, even with their wallet, because right now ERC-4804 only support read-only web contents to display. So they do not require wallet, but they are able to directly access Web3 content that is hosted on top of Ethereum. So currently we are working with one of the top browsers in these 4 browsers. And also, since this is a significant project, we are also contacting Ethereum Foundation for more support for this massive adoption. Another interesting, I would say interesting blocker is that we found that some malicious reporters that report us says, hey, our website is malicious. It contains some excessive spamming information. So we found this report that is filed to, for example, Google, from Cisco, Firewall, Kaspersky, antivirus, their database. So we have to submit a counter report, asking, hey, this is something that we build, and everything now we display is on top of Ethereum, and you can check the contract we call, the message we call, this is the standard. And for Google and Cisco, they just quickly fix all these issues. And so now browsing, for example, all this website that I can demonstrate, right now there's no such issue at the moment. Well, at the same time, the capacity, actually we have no idea how they work, especially we have submitted multiple reports, and especially from our community members. But still, they are still says that they are reinvestigating all these things. So if you have any ideas or the broader Ethereum community can help, and that would be greatly help to us to solve this problem. But still, when we make this full this like things forward for the Ethereum, definitely there's always some bad guys that would like to attack us secretly. And so another blocker issue is the storage issue, which I just mentioned. On top of Ethereum, if we want to deploy the whole the website or whole the data, in general, it will cost more than $10 million per gigabytes costs. That's just too much expensive. so compared to, for example, AWS Cloud or even Filecoin. So definitely we need some solutions to solve two problems so that we are able to really realize our goal to make sure we are able to deploy all this, for example, all kinds of these rich applications that on top of Ethereum on layer 1 or either or layer 2. So current solution that we found is to able to use Arbitrum Nova with DAC. So Arbitrum Nova is a layer 2 of Ethereum, and it has a data availability committee so that they do not need to upload all the transaction data on top of Ethereum, so that it's very friendly to upload a large amount of data on top of Arbitrum Nova. And this is something that we also experiment on top of with the Vitalik blog. And we are also exploring with lower cost solutions building on top of Ethereum DA, so that we are able to reuse Ethereum trust model while we are able to roll out all this transaction data using DA. And thanks for the Ethereum ESP program support. Right now, we are working towards solving this problem so that we are able to reduce the cost to 1 to the 1,000 of the current Ethereum storage cost and be able to scale the whole storage capacity to petabytes. So if you're interested, you can also find the Ethereum latest announcement on the layer 2 community grants. And besides all these blockers, there are a lot of things that we need to improve and also need to extend the whole ecosystem. So one proposal that we are also working is ERC-4804. That is built on top of ERC-4804. That's to build a file system-like interface. So that we can imagine the smart contract can provide kind of like file system interface, and so that people can interact with basic file system like read-write operations, and be able to, for example, to synchronize the local data. Imagine when in the Web 1.0 we have FTP, but so we also create a Web3 version of FTP synchronizer or uploader. So that following the standard, we are able to synchronize a list of the folders, files locally to the smart contract. And this is something, the tool that we are built for the uploading the Vitalik block, just using single command, providing all the information, including, for example, the private key definitely that is required to sign the transaction, and everything will be automatically done by this uploader. So this is something we have done. And that is another ERC is ERC-5219 that is created by PEEPanEIP 1. This is basically provide more advanced semantics to request resources, and so that we can provide customized headers and error code for ERC-4804. That is because like the customized headers is a feature in HTTP, where HTTP, besides we can see the web contents like images, there's also another side information that is put in the HTTP request and response in terms of the headers, including, for example, MME, status code, other, for example, compression, all kinds of this information. And so we need some customized header to fully support this. And the ERC-5219 is the one that we are incorporating with ERC-4804, so that we are able to support much customized features that HTTP has. And also other standard like ERC-6860, which tells how to map the name from the ENS to the corresponding address, contract address, how we are able to, for example, find the corresponding text field of we call content contract versus, like, if you're familiar with IPFS, that's called a content hash that points to IPFS. Since we now calling the contract, so we create this contract address, content contract to basically to map the corresponding address. This is the test record that we search, and that's also standardized in 6860. And there's a more standards that we are thinking about, for example, how we are able to put the more standard debug information in the for example, in the headers, so that for the developers, they can easily figure out how the contract is being called, how many gas has been used, what is the actual call data, which contract is called, which token, which chain ID is being called, like, for example, is either on mainnet or on Arbitrum Nova. So there's a lot of interesting ideas that are building around, surrounding. So yeah, happy to be contacted and send information to me if you're interested in the standard and how we are able to make this standard to be more adopted by more applications and be able to encourage more, for example, full ecosystem to more people. So that's pretty much what I have. Happy to answer any questions, or I can give some quick demo.
I think the presentation was really great. I was really excited to see so many other proposals working around 4804, and we are trying to extend this standard to be used by the users. It would be nice to have a demonstration, and we do have time. So yeah, if you would like, please go ahead with that.
Sure. So yeah, this is my Firefox browser. So I have installed this is Web3 URL. So on the right hand side, you can see this this basically is a Firefox extension. So Firefox extension Web3 URL. So you can find the corresponding extension to help to basically translate the Web3 URL to a gateway. So here, for example, I type Web3 and then vitalikblog.eth. So basically, I want to call the contract that hosts the Vitalik block as a copy. So here, then it will translate to the HTTP way, like a gateway similar to IPFS. IPFS have also multiple gateways, like IPFS.io or IPFS like Cloudflare. So this is a gateway run by us, but definitely we are encouraging more people to run their gateways. So this is the basically the how the gateway returns. Also we have some debugging information. For example, when every time it call the HTTP request, and then it will basically translate this HTTP request to tell, according to our Web3 URL standard, what which contract is being called, and what is the call data, and how to resolve the corresponding content, and also the return types, and what is the chain ID of the name service, and also the corresponding chain ID that holds the whole contract of the Vitalik's content. So everything you can find the corresponding data here. So basically everybody is able to reproduce the data by calling the corresponding contract and also the call data. So I can also, for example, go inside the Vitalik's blog. And the good thing is, like, since we are highly compatible with HTTP standard, so a very good feature of HTTP, for example, the relative path will be automatically supported. For example, taking this example as an images, if we inspect these images in the URL, it is basically using the relative path to tell us, hey, this is the some parent directory and then subfolders of image and something like that. And in the HTTP standard, this will be automatically translated to some absolute URLs, and then will convert to the absolute request of HTTP. And since Web3 URL is also compatible with this, so that all these requests will also be either translated to Web3 requests. This is defined in the protocol relative URL standard in the basically RFC of the whole URI, and all the HTTP one, so that we just naturally support all these rich features of HTTP in the standard. So that you can find the corresponding, for example, robot1.images called that in the either in the for example in the HTTP way, and then the corresponding the call data. So this is the and basically the example that we so right now we experiment, and I think I really would like to convince Vitalik one day, say, hey, why not you use the centralized server to host your website, and you should use Ethereum to host your website, and use smart contract to control all the content and be able to access it just in a fully decentralized way in using Web3 Access Protocol. And this will be something that we really believe something will happen, and will be happening for more Web3 users and developers. Yeah. So yeah.
Awesome. That was great. I really hope your wish come true about Vitalik coming to this page, and yeah, we can make people understand that difference. I have one question from your demonstration. Probably you mentioned about like when we are looking into all kind of data information, those are available on site. It was about resolving it, and also the proposal mentions about resolve mode. Could you maybe briefly explain what are the resolve mode available using this standard, and in which particular case, which mode will be helpful?
Oh yeah, that's great. Actually, that's a great question. I think the best way is probably to go to our Web3 URL website, and there's a way to tell how the resolve mode works. So the resolve mode basically tells that when given a Web3 URL, how to translate the corresponding path and query into a EVM message, EVM message call data. So there's two modes. One is called auto mode. In the auto mode, so the front end, which when we receive this Web3 request, it will basically figure out the corresponding method and corresponding at least arguments by separated by the slash, so that it's able to say how, oh, this is calling the balance of the method, and with the Zuckerberg as the address as the argument, and the corresponding data will be returned in 256. So the auto mode is more designed for existing smart contracts that has no aware of ERC-4804, but user would like to, using a single link, be able to query the data on those single contract. It can be images, it can be also any like a Solidity API return types. So that like I can easily share a link, say, hey, look at this person, this is the balance, and this is his balance, or look at the ownership of this for example, NFT, and just paste the single link here. And also there's a called manual mode. In the manual mode, it's quite straightforward. It said, hey, I don't want to do any further interpretation of the path and query. I just put the whole thing in the core data and let the smart contract to decide what the data should be returned. So this is more designed for the decentralized front end contract. That is the contract designed for the front end, so that they have fine-grained control what the actual user would type in without doing further translation, and put the whole thing in core data. For example, in the Vitalik block, so every time when we, for example, enter for example a link, then the whole thing right now is using resolve mode, so that so we can check that this is in the manual mode. So that the core data is just actually the whole to link or whole path of the, for example, images or travel time, all this data, so that we just look at the corresponding this data as the key, and then find the corresponding data from the EVM, so that we do not lose the corresponding information that the user would like to pass to the smart contract. So this is two modes, and actually we are adding the third mode that is supported by ERC-4812, EIP 5812. Let me see. Let me check the name. It's EIP 5219. Sorry, I remember 5219. 5219. So which will be able to add additional mode to support more fine-grained headers of that Web3 request has. For example, this is a contract interface. Let me see, contract interface. Why not? It just open. Okay. So a contract interface that contains a list of the headers and all this information that those side information that our HTTP request has. So so we are basically first starting from a very simple way to translate this message. Now we are gradually going to more and more complicated ways to how to resolve this path and query or from Web3 URL. and so that we are able to satisfy more complicated applications. Yeah.
Yeah, that's great. I mean, I'm happy that you guys did not try to edit the same EIP, but have proposed 5219 as a separate EIP to introduce the third mode that could be used. I have another question, which is related to NFT and images, like we were talking about that this standard help access to that as well. I'm curious, there is this another proposal 4883 composable SVG NFT, and it was also compared with the present proposal. Could you explain us the basic difference between this and that proposal?
Oh yeah, so I think this is in the different layers of the different proposals. For the Web3 URL, it is more like front end. That's why we call it access protocols. It tells, hey, how we are able to access the data from the front end, most likely the browser, but hopefully in the future can be supported by other tools like WebGet or curl. So in the next step is to be able to how to organize those data, be able to return to the front end. And the way how to organize data is highly defined by the smart contract, how it is being implemented. And the composable NFT is one of the, I would say, closely one version with the ERC-4804, because we need a way to how to compose. For example, actually all these, you can see all these images, they are already deployed on Ethereum smart contract. They are also in some way they are composable. For example, background, also different hair or different bodies, all those things, they are composable. So we need a way to be able to put these different, sometimes they call layers or components composed together, so that we can return a uniform way to the front end, so users can easily be able to browse it, or the developer can easily be putting all these components and using other tools to just upload it and put them together. So we are solving different layers of problems that the future application on top of Ethereum, like for example, especially NFT, they are facing. So we are very happy to see how the mechanism Web3 can help to solve this problem, especially those SVGs. They need a way to render those content directly on top of Ethereum. So we are highly related, and also we are see how we are able to be able to satisfy their needs, so that in the future we would like to see that in 5 or 10 years, all the images, they will not using like HTTP or IPFS, they will use Web3 to say, hey, we are already on Ethereum, so we should display all this data on top of Ethereum.
Interesting. That's the hope here, like move everything on chain so we can literally migrate to Web3 world.
Exactly. Yeah.
All right. So my next question is with respect to the process, the EIP process. You have documented this EIP, and we learned that there are a few more to come up. Would you maybe share your experience as an ERC author? How did you find the process in general? And if in your mind, is there anything that we could improve to like further help authors document their proposal as a standard?
Yes. Yeah. First of all, I would like to express my appreciation for all the help from EIP editors, and also definitely Pooja and like UI working group from Ethereum ecosystem. Actually, ERC-4804 is my first EIP. So when I started writing this EIP the first time, I think in February last year, actually there's a lot of issues that I even though I have a PhD, I wrote a lot of academic papers, but still the whole process needs to get familiar to understand. So for example, the common mistake I have been made is like I misunderstand what's the basically for example the rational, why we need to put rational there, and why we have this for example where to put the motivation, and so sometimes I just mix them and then write this content that originally should put in the motivation, by putting the rational or putting the rational in motivation, all kinds of things. But I'm very happy that EIP editors are very promotive to help say, hey, this is the you should put this content in this section. You should organize this data in this section. And sometimes even help me to rephrase the whole sentences to make to be more clear. And help me say, hey, you can check out the EIP, the reference to find out the details. So that is really helpful because feedback is really important to make the whole thing to be from draft that is still very naive, but to the final version that people can read it and can understand it, can be able to develop on top of it, especially for the, for example, for the developer, they develop this native integration from community. The first thing they have to is to be able to understand the standard clearly so that they can reproduce all the work that we try to explain in EIP. So this is something that really inspired me because now somebody really can just follow the work, can do these things. And thanks to the help from the EIPs and also the communities. And also I found the EIP process become more and more automatic, especially there's a lot of new the bots that help to check out these formats. And then, so for every time when I, for example, made some modification, I was like, oh, it looks like there's some new corrections I need to make the whole EIP more, I would say, readable. So I think this is a really, really good iterative process to help the whole process and be able to benefit a lot of newcomers so that they are able to quickly understand how to draft this EIP, how to be able to let the EIP to be more understandable, to be able to let more, not only Web2 Ethereum ecosystem, but more people outsider be able to come and be able to contribute. So yeah, I think this is something that I personally would like to contribute some of the discussion comments, like for example, UI working group. And definitely there's also a lot of help from there to see how we are able to, what kind of applications and what the, how to, for example, like something that polished to be more Ethereum native. For example, the text record, we originally used in Web3 record text record as the mapping, and then Sam Wilson said, this is something not like easy to understand. Why not using contract content? And this is a content contract that is already have similar version in ENS, and people can quickly understand what is going on. Yeah, this is a really great suggestion. And so a lot of these things then may adopt together. So I think we hope that the whole things like become community owned and also be able to contribute by all the community members. So we welcome everybody to have any good ideas, be able to co-contribute to in this all the EIPs by adding more EIPs or polish existing ones. Yeah.
That's awesome feedback. Thank you so much for that. I mean, it's really interesting to see that you have actually followed the process, which was 6 months ago. Definitely, there has been a lot of changes since then. I think when 4804 was introduced, there were most of the things were manual. EIP editor has to chime in to let you know what needs to be fixed. But these days, with the help of EIP bot and EIP bots, I think we are trying to do most of the thing in an automatic way. However, we are still keeping this manual interaction there. We are also organizing EIP editing office hour for any new authors to maybe come and ask their question if there are any. So I will definitely take your feedback and share it with other editors and your good words as well. So we can increase the contribution and participation of community.
Yeah, that's great. Yeah.
Awesome. I think it's time to wrap up. Any final thoughts or message that you would like to share with the community today?
Yeah. So I think one thing I would say that like we are now, especially with the scalability roadmap of Ethereum is gradually roll out, for example, EIP-4804 and then shorting. We believe that we are at the door of the new world that is purely built on top of the Web3 that is able to be more fair, to be better, to secure all the assets of users and be able to offer much more freedom, especially from Ethereum technologies. So we hope that there are more and more people can work together to contribute all kinds of these ideas through EIP process, and also hopefully through the ERC-4804, from all aspects. So welcome to build the future Web3.
Thank you so much. These are awesome words. We really appreciate you taking out time to provide an overview of EIP 4804, a Web3 URL to EVM call message translation. We look forward to see standard being adopted in upcoming projects. On this note, thank you to all our YouTube viewers and ECH podcast listeners for following this talk. Don't forget to like and subscribe ECatHerders YouTube channel. Should you have any question on this EIP or any other topic, let us know at ECatHerders Discord. Cheers.